Hey friends, we are going to kind of combine a concept we already know, something we've done, with what we're currently learning, which is rational functions. So keep in mind that a rational function is a ratio of two polynomials. So that's what we've been doing. Oopsie. Where you have a polynomial on the top and one on the bottom. So like a fraction function is what I would call it. And what we're going to look at today is some pieces of information related to that. So here's our rational function. We have a top and we have a bottom, and each of those are kind of functions of their own because they are polynomials. Okay, so it says here that they have no factors in common, and basically what that means is if you factor the top and the bottom, none of them cancel out. We will eventually have some that do, but for today's lesson, they will not have any factors in common. And then there's two features of the graph that you need to know. You need to know that it will have zeros, keeping in mind that zeros are where it's going to cross the x-axis when you go to graph it, because your y value will be 0, and so it'll hit the x-axis at that spot. And that is when the top equals 0. The top. So we're going to figure out when does the top equal 0. Then, in the bottom, it says f of x is undefined when it's 0. You already know that you can't divide by 0. I'm choking, sorry. So we're going to look at the bottom, which you don't spell like that. And we're going to find out where that equals 0. And then that will tell us where we have vertical asymptotes. Meaning, a vertical line that your graph is not going to touch. So the top will tell us actual zeros. And again, remind yourself that that means like x-axis crossings, because your y will be 0. And the bottom equaling 0 will locate vertical asymptotes for you. So then you have this whole box of what to do. And this is definitely a process that you need to know. Why do I keep doing that? I have no idea. Why did I just do it again? I double have no idea. All right, so this is something you definitely want to know. I'm going to put yellow there too, because I know you need to know that for the AP test. Make sure that the inequality has 0 on the other side. When you are solving to find zeros, you have to let it equal 0. And then you want to make sure that you have a single rational function. One on the top, one on the bottom. And then, like we said, they won't have common factors. And if they do, we're going to cancel them out. So here, keeping in mind that g is on the top, this next step is having you set g equal to 0. So that will be the top. And then it's having you set h equal to 0. And that will be the bottom. So you're doing them separately. And then you're going to find all the values to include on your sign table. So you're using zeros from the top and zeros from the bottom. You're going to create a sign table like we've done before. And then it says be careful to mark the values where the bottom equals 0. And the reason that's concerning is that you never want to include those in your solutions because you can't actually have a 0 on the bottom. So you would never want to include those with brackets or have those as a part of your answer. Then we're going to do test points just like before. So this process is all like what we did before. We're going to have a sign table after we find all of our zeros. And then we're going to interpret the sign table, which just means like pick which parts of it match based on whether each region is positive or negative. And then it's asking us to use interval notation and think about endpoints. So keep in mind that this means not included. So that would be the appropriate thing around a vertical asymptote value. And then this is going to mean included. So we have to decide if it's or equal to something. All right, so let's put that into action. The steps are so lengthy, like what we just walked through, but the process is not that terrible. So I don't need to factor this one. I already have that. So I'm going to find all of the zeros. So from here, I would have x equals 2, and that's going to be one of my zeros, meaning that would, if I graphed this, be one of the places that it actually has a value of 0. Then I'm going to have -6 and +3 as undefined or vertical asymptotes. So if x equals either of those numbers, they're still going to go on my sign chart, but they are not zeros. The only thing that's considered a 0 is coming from the top. So I'm going to draw out my sign chart. I'm going to include -6, +2, and also 3. And then I'm going to choose test numbers in each region like we have. So something between there, in between here, and up above. And then we're doing what we did before, but now we have a top and a bottom, but it's no different. -7 minus 2 on the top would be negative. -7 plus 6 would be negative. And -7 minus 3 would be negative. So if you have a combination of those three things, that region is going to end up negative. Plugging in 0, we get a negative on the top. 0 plus 6 is positive. 0 minus 3 is negative. So overall, we would have a negative divided by a negative, which would turn positive. So the process is the same. It's just got that extra layer, literally. So 2.5 would make the top positive, and then +6 would be positive, and -3 would be negative. So we only have one negative sign that doesn't cancel out, so that region is negative. So keep in mind, this one's a 0, and these two are undefined. And then now we're going to test 4. So 4 minus 2 is positive. On the bottom, 4 plus 6 is positive, and 4 minus 3 is positive, so that entire region is positive. And then we go back and look for anything greater than or equal to 0. So this is greater than in here, and then this is equal to at 2. So my first region of positive is going to be from -6 to 2, including the 2, because that was an actual 0, but not including this -6, because that is a vertical asymptote and can never be included. And then the next place that is positive is from 3 on. So I would write 3 to infinity. You can't include 3 because that's a vertical asymptote. It came from a 0 on the bottom. And you can't include infinity because you can never get to it. So that, my friends, is the process. Here we're going to be a little bit more careful because we're not going to even include our zeros since it's strictly less than. This one is not factored, so we have to start by doing that. And if factoring is still an issue, then that's something you want to work on, because the assumption is you can just do that as a step in the right direction for these problems. So I factored the top. I'm factoring the bottom. What makes 25? That adds up to 10. And there we go. We don't have any factors that cancel from top to bottom. So my zeros are going to be at -2 and +2. So I'm going to have x equals plus or minus 2 as zeros. And then I'm going to have x equals 5 as a vertical asymptote. And you can see that that's down below written twice, but they would have the same value. So when I go to make my sign chart, I'm going to have a -2, a +2, and a 5. This negative and +2 are zeros, and the 5 is undefined, and I want to make sure I don't include that. Okay, there's a lot of factors here. Let's pick some numbers in each region. So something less than, in between, and greater than. And I'm going through these factors right here. Plugging in -3 gives me a negative and a negative on the top, and then a negative and a negative on the bottom. So I have 4 negatives total, making that region or interval positive. In between -2 and 2, I'll test 0. 0 plus 2, 0 minus 2 on the top, 0 minus 5, 0 minus 5. I have 3 negatives altogether, which is an odd number of them, and I'd end up with negatives in that region. Testing the number 3, 3 plus 2, 3 minus 2, those are both positive on top. 3 minus 5 is negative both times on the bottom, but that leaves me with 2 negatives. So overall, that region is positive. Using a 6, I would have a positive everywhere, which will leave me with a positive. Now this one's asking for less than 0, so strictly negative. So the region I want is here, and it does not say or equal to. So I don't use my zeros. I would write from -2 to +2, and neither of those is included simply because it's not an or equal to 0. All right, what I would recommend is that, the next ones are all kind of similar. So maybe turn the video off and try them before watching the video just to see. When you look at this one, there's no way that this top can be 0. So this generates no zeros because it's a 2. So there's no way it can be 0. And on the bottom, I have x equals 3 as a vertical asymptote or undefined value. So when I go to make my sign chart, the only thing on it is the 3, and it is undefined. So I'm going to pick numbers to the left of 3 and something to the right of 3. On the top, the 2 is always positive, and in the bottom, 0 minus 3 would be negative, so overall, negative. If I put a 4 in, the top is still 2, which is positive, and the bottom becomes positive, so this region is positive. So if they want something greater than 0, they're going to want from 3 on, but I don't include the 3 because it's not or equals to, and even if it was, I wouldn't include it because it was undefined, not 0. Hopefully you already tried this one. The only factoring I can do is to take out a GCF on the top, and I am looking for this to be less than or equal to 0. Here, my 0 values, or my zeros, will be at x equals -2, and my undefined values, or vertical asymptotes, will be at x equals -5. So both of those numbers are going to go on my sign chart. -5 is to the left of -2 on the number line, and now I'm going to pick values less than, in between, and greater than. So in this, the 4 is always positive. X plus 2, if I'm using a -6, is going to be negative, and then -6 plus 5 will be a negative on the bottom. Overall, a positive region. If I'm using -3 to test in the middle, I have my +4, a negative on the top, and a positive on the bottom. So with only one negative, I end up with a minus or a negative in that region. Testing 0, my 4 is always positive, 0 plus 2 is positive, and 0 plus 5 is positive, so that is a positive region. I am looking for less than or equal to, so that's going to be this negative region, keeping in mind that the -5 is undefined and the -2 was actually a 0. So when I go to write that, I cannot include the -5 because it's actually a vertical asymptote, and then -2 is actually a 0, so I include that. All right, again, I hope you have tried these, keeping in mind that squared means multiplied by itself. It might be, or like you don't actually have to write it out here, but just keep in mind that that means that. It also means that this part is always going to be positive because it's squared. And when you square something, positive times a positive or negative times a negative, it's always going to be positive. So from the top, I get a 0 at x equals 1, and then another one at x equals -2 for zeros. And then on the bottom, I get x equals +2 as an undefined or vertical asymptote value. So all of those are going onto my line. I'm going to have -2, 1, and +2. Where 1 is a 0, -2 is a 0, and +2 is undefined and cannot be included. Testing a number to the left, in between, and greater. -3 minus 1 is negative. The second top function is always positive because of the square. And on the bottom, -3 minus 2 is negative. That's 2 negatives, so that overall part is positive. 0 minus 1 is negative. The second part is always positive, and 0 minus 2 is negative. Those cancel out, and it's positive again. And then using 1.5 minus 1, I get a positive. The second one's always positive and a negative on the bottom. So this region's negative. 3 generates a positive on the top left. The top right's always positive and a positive on the bottom. So that is positive. They are looking for anything that's positive or equal to 0. So that's going to be here, here, and here. But I'm also going to remember to include my zeros in this one because it's or equals to. So when I go to write my answer, everything from negative infinity to 3, then also, to negative 2, but including negative 2, and then the next region all the way to 0. And so in this, all the way to 1. So this is positive, and this is or equal to 0. So I just keep rolling until I get to that 1. So basically everything over here, because if I had to draw this graph, it would come down probably here, and then it would be up here again, and then after that it's below, and then it's above. So if you're looking at positive or equal to 0, you're including this whole part, and then you're including this last piece. So we're going to go ahead and write that in. Since that 2 is undefined, we don't include it, but everything after that is going to be above. It's going to be positive. All right, so here, keep in mind that there are no zeros because you can't make the top equal to 0. And here you have x equals 1 as your only undefined or vertical asymptote value. So if you did a table with a 1 here, you'd pick a number to the left and right, but this bottom is squared, and when something is squared, it's always going to be positive. So in this problem, the top is positive because it's 1, and the bottom is positive no matter what. There's no way to make any of those negative. And so if they want where it is less than or equal to 0, that's no place because, sorry, I shouldn't have put a 0 there. I should have put a U because the 1 is undefined. There are no zeros, and the entire graph is above the x-axis or positive. So for what they're asking, there's no x's less than or equal to 0. So there's essentially no solution to what they're asking for because we didn't get any negative regions. All right, last thing we got to do is take a peek at how do you do this if they're given a graph. So here you can see that we've got a horizontal asymptote, appears to be at y equals 1. We have a vertical asymptote here that appears to be at x equals negative 3. There's another vertical asymptote here that appears to be at x equals positive 3. So you've got a 0. I'm just looking for other features. There's a 0 here, and there's a 0 at 2. So we'll call that 0, 1 and 0, 2. So those are zeros because that's where the graph crosses the x-axis. So it's asking here, where is the graph less than or equal to 0? Meaning, since we're looking at the graph below the x-axis, we can't do a sign chart because we don't have anything to plug into. So if I'm looking for places where it's going to be on or below the x-axis, I'm looking for this piece and this piece. So the way to write that is you're saying from here at negative 3, but not including that because it's a vertical asymptote, which is undefined, until I get to negative 1, which I am including because it says or equal to 0, and at negative 1 I have a 0. And then again, starting at positive 2, which is included because it's a 0, and going until 3, which is not included because it's a vertical asymptote. What about where f of x is greater than 0? So this has to be above. And actually, I should have written, just for the sake of having good notes, below the x-axis or on it. Whereas now you have to strictly be above. So above is this piece, and this little piece. So to me, this piece over here on the left, That is forever from the left until you get to the vertical asymptote, which is at -3, but you can't include that. Then this little tiny middle hill goes from -1 to +2 in between the zeros, but you can't include those either because they're equal to 0, and that's not what it's asking for. And then the last branch over here starts again at 3, which is a vertical asymptote, so it can't touch that, and then you can't include it, and then you go out to infinity, which you also can't. And then our last category is, where is this greater than 1? So now you're looking, where is the graph above y = 1 or on it? Okay, well, since that's a horizontal asymptote, it's never actually going to be equal to it, but it is above it in this branch and this branch. This middle part never goes above that. So my answer is going to be from -infinity to that first vertical asymptote. That would take care of this piece. Now to get this piece, I have to go from 3 to infinity. So up here you can calculate it using the tables, and here you just have to understand what they're asking for in each of the situations, and then you can visually find what you're looking for based on that. So in your notes, if you're keeping track and using the highlighting system, this is going to be your examples. These are examples, and then you have these concepts and definitions and such up above. And I hope that helps. Bye.